Hi everybody. In today's episode, I want to explore how we can use simple bash scripts to not just concatenate executions of commands and pipe outputs together. No, I want to explore how to use bash scripts to perform mathematic computations such that you can build yourself your own personal calculation library that supports calculations that you frequently use. So everybody, or most of us, thinks of bash as a shell, yes, and a scriptable shell that we can create scripts for. However, bash is never used for interacting computationally and performing computation. So I would like to find out in this video what we can do. And the first thing that I found was by just looking up the bash tutorial on W3 schools, that bash can deal with basic numbers. And by the way, at the end of this video, I would like to have a simple script in bash where we can compute some basic things for ourselves. So this is not going to be a typical bash script. This is going to be a mathematic bash script. Yeah. So I find this very untypical. This is a very untypical use of bash because normally when you try to compute anything, you're just going to use Python. For example, Python 3, and if I just want to compute something, I'm going to type that here and get a result, and I can automate that in a Python script. That's what Python is good for. However, we're going to do that in bash today. So what I found is that bash supports... Where is it? Bash supports numbers and basic computations. Here, I think it's here. So bash data types. First of all, strings are supported, which most of you know. We can create variables and give them a string value. I don't know if we can do this directly in the terminal here. Hello world. Let's try that. And if we echo the greeting. Oh, it works. I didn't know that. I didn't know we can just script directly in the terminal without an actual script file, just like in this Python script here. So we can create variables interactively and echo them out directly. That's nice. And this is the interesting part. Bash also supports numbers, and the tutorial says that numbers in bash can be used for arithmetic operations. Bash supports integer arithmetic natively, such as addition, subtraction, multiplication, and division. And how it works is you create a number, a variable, let's say 1, and you can echo that variable. It contains the value 1, which is a numeric value. It's not a string value as in this. So now it would be a string, I think. Yeah. So without quotes, it's a numeric value. And then we can create another variable. A is 1 and B is 2. And if we do echo, and this is the confusing part because bash is really not optimized for computation. You have to use the $sign to evaluate the expression, followed by double or contained in double parentheses a plus b. So that's the syntax for computing stuff in bash. And you get the results like so. Without the $sign, I think it does nothing, but something must be happening under the hood. I'm not sure. What happens if we just use single parentheses? That doesn't work. Yeah, but because the single single parenthesis syntax is reserved for grouping commands for subshell executions, as far as I know, but not relevant for our course. So you have to do the $, double parenthesis, and as you can see, if we evaluate it like this, then Bash will understand the result of a plus b as 3 and try to invoke that command. So this expression is replaced by the result, and because we hit enter, Bash tries to execute this as a command. And that's why we have to also prepend echo to echo out the number 3, because this expression here evaluates to 3. So we want to echo the result of this, and this is 3. This is how it basically works, and this is how Bash supports computation. We can also type the numbers here directly. We can just do something like 7 multiplied by 3 divided by 8 plus 5. So this is simple integer multiplication, division, and addition. And the result is 7. Obviously, this will never be the result if this was a floating point operation. This is simple integer arithmetic, so everything is rounded off. And we can just do those integer arithmetic. We can just do that integer arithmetic natively in Bash. And using this approach, we can already do something. For example, let's switch into the projects directory and create our Bash, our compute shell script directory, compute shell. And let's create a file and call it computeshell.shell or compute.shell. And it's a bin bash script, and let's say that we want to provide a usage instruction, and let's just break this down very simply. This is just printing out usage, then the name of the executing script, and then the arguments here, number 1 and number 2. And what happens with number 1 and number 2, that would be an addition, and that would be the first example that we want to do. We want to create a script that adds 2 numbers. Super simple. Now, and I'm not an expert in Bash syntax, so if I have to look up something, then please bear with me. If the argument count is not 2, then the user is required to provide 2 arguments and the usage is printed. Now, how do we check the argument count? Bash argument count. We do that using the $hashtag syntax, I think. Okay, so let's try to do that. $hashtag contains the argument count. If the $hashtag is not equal to 2, then let's indent the echo. And then let's close the if statement. And I think that should be it. Now in the bottom right terminal below my webcam, we can invoke that. Let's go into the compute shell directory and let's let's first give the script permissions, and let's call the script without any arguments, and it's throwing an error. Where did I mess up? If the argument count is not equal to 2. And that's also one sensitive point about Bash that you all have to be aware of. Bash really has a hard time distinguishing the arguments provided to processes that you invoke. For example, you invoke something like a set command, and you replace something, whatever, some string there, and you do something here. And Bash really has a hard time distinguishing the syntax of the specific command, the process that you're invoking, because here you're invoking the set command and everything followed by that is specific to the set command. And Bash has to distinguish between that specific command syntax and its own syntax. And here we are doing something, and the 2 and the bracket here, they are not separated out, and there must be a space here. I can't explain why there has to be a space in this specific case, but Bash is really not able to parse this script if there is no space. As far as I know, it can't distinguish the number from that bracket. Let's try to compute again, and as you can see now we get the usage instruction here, because the argument count is not equal to 2. Now, can we actually test the argument count here in the echo shell? Let's try it here. In the echo command, I mean. Yeah, 0. What if I do, just for debugging, provided number of arguments is, the number is this, and now I invoke that command with 0 arguments. As you can see now, the provided number of arguments is 0, and if I invoke it with a lot of arguments, then the provided number of arguments is 7. So this seems to be working. So this is a placeholder for the number of arguments, or not a placeholder, that is not really adequate. It's a special variable that is automatically assigned by the shell. So, let's keep that echo statement just for the time being. So we are printing out usage, and if the number of arguments is not equal to 2, and if it's equal to 2, maybe we should also exit here. We should exit the shell, because we will only want to continue if the number of arguments is correct. And now we can just perform some computation here in this echo command as we learned before. So let's try to add some numbers here, as in the tutorial, as in the Bash tutorial. Where was it? It was in the data types section, and then this right here. Okay, so we need to compute something like this, number 1 plus number 2. Now we could create variables. Number 1 is the first argument, and number 2 is the second argument. And then we output the addition. And as you can see, if we execute it, let me just clear the console again. If we execute 7 and 4, then it outputs the addition, the sum 11. So that seems to be working. I would be curious if we can compute this without allocating those variables here, just by inputting the first and second variable directly, the first and second argument directly. I'm not sure if that works because that syntax is quite convoluted and I'm not sure if Bash can handle it. Let's see. And let's execute the same command again. And it seems to be working. Did I save? I think yes. So this seems to be working. That's awesome. Okay, so now we have a very simple tool to sum two numbers, which is completely over the top, but let's say we want to create a library of math functions that we want to support. Then we can do the following. We can allow the function to accept as a first argument the kind of computation to be performed. So let's call that first argument the function that we want to execute. And there will be a couple of functions. For example, functions will be sum or let's do something more interesting. Maybe acceleration, or let's keep it simple. What do we want? Yeah, let's say we want to support a function, and a function accepts a variable number of arguments, like so. And the number of arguments is specific to the function that we execute. And let's say the first function will be the sum, the first supported function. Now how do we compute the sum of variable arguments? That would require a loop. We can do that as well. So let's look up the bash loops here. And probably, yeah, we have to do a while loop while the count is less than the number of arguments provided. And then we sum something. And it seems that this double parenthesis syntax oh, that's interesting. That's also a math expression. So the increment operator seems to work. So this is incrementing without using that value as a variable using the $ operator. Yeah, so let's try to create as a first function that we want to support a sum with variable argument count. So we do while the okay, wait, I'm just thinking, how do we loop over all the arguments? Bash loop over arguments. Oh, okay, there's a special variable that represents all the arguments, and we can just for loop over that. That's awesome. Okay. So there's the special variable, and it is probably an array type. Let's have a look. There's the bash manual here, special parameters. Is that even documented in the bash man pages? Special. What if I search for $sign and then the at? It's not listed there. So we probably have to default to this documentation. So we want to use $@ Okay. The shell treats several parameters specially. These parameters may only be referenced. Assignment to them is not allowed. Special parameters are denoted by one of the following characters. And then there are those couple of special parameters, and we use this one, which expands to the positional parameters starting from 1. Okay. Well, okay. So that seems to be working, and we can just loop over the contents of those positional arguments. So for argument in $@ already forgot the syntax. Do oops. And we do the following. We do sum equals sum plus arg, but we can't do that in Bash. We can do that in probably any other programming language except Bash. We have to do this evaluation, I think. I don't know if I have to use the $. Yeah, probably I have to. And then this done. And like this we sum. And then we print out the result. Sum. Do I even have to use the quotes here? Sum. How about this? And we only use this function if, or we only sum the arguments if the function that we specify, the function is the function is the first argument. If the function is equal to sum, then oh god, my Vim skills or touch typing skills are really at an improvable level. So if the function that we provided equals sum, then we do something here. Obviously this won't work as it is coded right now because the first argument is the function name. And if the function name is sum, then we sum all the arguments. However, we want to skip the first argument because, again, the first argument is the function name. So we have to somehow skip the first argument. How do we do that? I can only think of weird coding hacks now. Probably the for each is not ideal. Maybe we can remove bash remove first array element. Okay, there's this delete function. I don't know if I like it. I don't really like it. So if the function equals sum, then for every argument in the argument array, Yeah, we have to probably skip first argument. And that is, does false exist? No, let's say it's 0. And for the first argument, first arg skipped is not true, and we skipped the first argument by saying this. If, oh god, this is horrible code, sorry guys, but please post any improvements in the comments. This is just an example how to perform math stuff in Bash. If the first argument skipped is 0, then or if it's not 0, does it even exist? Right. So basically this variable is there to skip the first argument in the argument count, in the argument array. And it's 0 at first, and in the first iteration I want to set it to 1. And after that the function knows that the first argument is already skipped and all the other arguments can be evaluated. So if the first argument skipped is 0, then we skip it. Can we break? Maybe we can break in Bash. And then let's end the if. Maybe this works, I have no idea. Let's try. So we provided 2 numbers of arguments. In line 12 there's an error. Let me just enable line numbers so I can see what line 12 is, and it's this line, and if the function of, obviously that is not that has to be evaluated, if the value of function equals sum, again, wait. Some integer expression expected. Ah, yeah, of course. So we can't check if strings are equal. For strings, we have to use this operator, as far as I know. And this seems to work partly. This is just exiting the application without doing anything. So wait, after echoing this sum, we can exit the application because then the operation is done. If we reach the end of the code, however, then we can just echo no computation performed. Since, well, no computation performed. And we can just check if, technically we can also check if the function is equal to the name sum or any other future supported function. Well, anyways, let's compute. And compute 7.4 doesn't work because we haven't specified the function. So we want to compute the sum for 7 and 4, and the provided number of arguments is 3, and now it's printing out the usage. That's because we still have hard-coded the number of expected arguments. So I think this, we can throw this out, I think. Let's say if the first argument is equal to help. Okay, let's try. So executing compute sum of 7 and 4 now computes the sum of 7 and 4, which is 11. Awesome. We can also remove the echo. So now we get the result. That's it. If we type help, then we get the usage, which is super awesome. Okay, I'm quite happy with that. And let's see if we can really provide a variable argument list. Let's say just 7, and the sum is 7. Awesome, that works. -2, super. 8, 1, 5, 2, 10, -5, or -6. And that's 18. So it seems to be working. We now have created a small script that sums up an arbitrary list of integers. Obviously, this is not very powerful yet, but this covers the basics of what we can do in Bash. Now let's create the next function. So if the function is not sum but exp, then we compute the, or let's call it pow. Then we compute the first argument provided to the power of the second argument provided. So let's try that. So the first argument provided is in variable 2 because the first argument is the function name. So the first argument to the power of the second. So basically we have to do a while loop or a for loop and loop for a couple number of times and compute the power. I think we need to use a while loop. While, let's use count is while the count is not equal to argument 3, which is the exponent, then while that's happening, do something and done. I just assume it has the same syntax as this for loop. Let's just do something here, do something, and see if the error goes away. Yes, it does. Okay. Now we do something and we do, let's just test this. So we want to compute the power of 2. We want to compute 2 to the power of 8. That doesn't work because not equal doesn't exist apparently. And oh no, that's not true. The count is not assigned. The count variable does not exist. So we have the count, which is in variable number 2, in argument number 2, and we have argument number 3. No. Wait. Let's make this a bit better. Exponent. Yeah, exponent and base. Okay. So exponent is argument 3 and the base is argument 2, while the count is not equal to the exponent. we do something. We multiply the results. Well, the result starts with the base. Base result is equal to base or result multiplied with the base, and we have to put that in double quotes and the $ syntax. Base multiplied with result or result multiplied with base. And I think for the first value of result should be 1, because if the exponent is 0, then the result will always be 1. Let's try. So the not equal does not work. Is it really not a valid operator? Is it NEQ? Wait, where's the browser? There it is. Operators. Not equal to. There it is. Less than is also good. But technically not equal to should work. And obviously we have to count ++ here to increase the count. Oops, what am I doing? Visual. And I think the issue is that we don't have a count variable. Yeah, we don't have a count variable, so bash expands this to an empty string. So this whole while expression evaluates to while bracket empty string not equal to something. So this is effectively the same as while not equal blah blah blah. And that's why it's complaining about the unary operator, because a unary operator is an operator that acts on just one variable, which is not the case. So we have to give the count a value. I think this should work. And this is power. This is a power operation. So we compute the power of 2. Well, we compute 2 to the power of 8. Doesn't work. Why doesn't this work? Because we don't print out the results, obviously. We have to print out the results here. So let's try again. And it seems to work. We have our own power function and the result is correct, 256. What if we do 2 to the power of 16? That's 65,536. That's also definitely correct. What about 2 to the power of 3? 64. Okay, wrapping this up, basically this is how you do basic integer operations, and you can do it to arbitrary complexity, obviously. But what if we want something a bit more sophisticated? For that we can use floating point operations using BC. According to this guide here, there's the data types section, and somewhere down here it says that data types are limited. Bash does not support floating point arithmetic natively. For such operations, consider using external tools like BC or AWK. So let's try to implement some floating point operation using BC, and that should be installed on any Linux system. BC is an arbitrary precision calculator language. And BC is a language that supports arbitrary precision numbers with interactive execution of statements. And are there any examples here? By the way, there are some similarities in the syntax to the C programming language, but which is quite convenient for us. So no new syntax that we have to learn. And we can the following expressions are supported. Minus expression is just a negation of an expression. Plus variable is an increment, etc. You all know that stuff. Expression plus expression is just the sum of two expressions. The division, modulo, exponentiation. Is it even called exponentiation? I don't know. No. Yeah, the first is raised to the second. It's the power operation. These are the parentheses to alter the standard precedence, etc., etc. And this is for floating point operations. We can even do the square root and some other stuff. But this looks very, very promising. It even has loops. Crazy. Whoa. It has loops. Okay. So let's see what we can do with it. I would say a nice floating point operation would be a let's compute the escape velocity of a planet. Escape velocity of a planet. And it should only depend on a single variable, which is the gravitational acceleration. So we can just compute the escape velocity. And by the way, for those who do not know, the escape velocity is the velocity at which something has to move in order to escape a planet's or whatever mass's gravitational field. So if you want to shoot a rocket off Earth and you want it to escape Earth's orbit, then you have to accelerate it to the escape velocity. And of course, the bigger the gravitation on a planet, the bigger the escape velocity. For example, on Moon, the escape velocity is much, much smaller than on Earth. So there are two variants of the escape velocity. There's this first variant, which takes the gravitational constant into account and the mass of the planet, and the d should be the diameter. Is it? No, this is the distance from center, so it's the radius. Yeah, and there's the other variant, on which just requires the gravitational acceleration and the radius. I think for our case, the first variant would be more interesting because it takes two arguments, the mass and the radius, and the other one, the gravitational constant, is a fixed constant. So let's create a new function. Because that's something that we have to compute every day. We need to know the escape velocity of the different celestial objects every day. So that's why we should include it into our into our super powerful compute script. Our compute script is so useful. It now allows summing up numbers and calculating the power of something and the escape velocity. That's the most useful script ever. But let's try. Gravitational, no, escape velocity of a, well, escape velocity. Let's just put it like this. Oops. So, escape velocity. If the function's name is called esqv, which is the escape velocity, then we perform a computation using BC, and now we have to find out how BC is used. So let's go to a new terminal and try it. So this is BC. It opens a shell, apparently, a subshell. And here we can just type stuff. Yeah, and that seems to work. Now, what happens if I do a floating point division? That doesn't work because that's okay. So it still seems to handle the numbers as integers. What if I do 6.0 divided by 7? Still 0. So let's see what's going on here. Float. If we search for precision. So BC is a language that supports arbitrary precision numbers, which is what we need. But do we have to set the precision somehow? I think somewhere we have to define the number of decimal digits, no? So let's have a look at a BC example. I don't think there's any example in this man page. Oh, there is? No, there's not. There is. This is an example for the BC language even. And here at the beginning of the script, it says scale 20, so that might be the okay. If BC is invoked with the -L option, a math library is preloaded and the default scale is set to 20. The math functions will calculate the results to the scale set at the time of their call. And the scale is the precision. Yeah, because BC scale max refers to the number of digits after the decimal point is limited to blah, 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 blah. Okay, but that should be the precision. That's fine. So let's try to set scale to 20. And let's do 7 divided by 8. And as you can see now, we have a floating point operation with 20 digits of accuracy. We can even do scale 100. And then let's do something like 7 divided by 6. And that gives us 100 decimal digits. So we can have arbitrary accuracy here. That's good. And if we use BC-L, we get 20 digits of scale by default. So let's BC-L, and without setting anything, let's try 6 divided by 5. And as you can see, we have floating point operations here. Okay, now BC-L is running in an interactive mode. I don't want that. I want to use it from the command line directly because I want to script it here to compute the escape velocity for our small little program. Let's try to find out how that's done. Maybe standard in. Wait, it must use standard in because bc-l is now listening on standard in for some computation, for some request, and then printing the result to standard out. So we can definitely do bc-l, and then we can echo something into that, 5 divided by 7, pipe that into bc-l, and let's see what the result says, and we get the result like this. So that's perfect. That means to compute the escape velocity, we can create a variable, escape velocity. Let's do it. Let's call it vescape. That's more academic. So vescape, the velocity of escape is equal to the square root of something. And now we have to somehow use bc-l, and I think we need to evaluate the function here somehow. How do we do it? I think we need to do this. And now we can do that. So this is a function evaluation as far as I know. I might be wrong, however. No, I have to look it up. So let's go back to the bash tutorial. Bash operators, bash functions. How about bash script? No. Wait, bash evaluate function in variable. Maybe something like that. I'm not sure. Let's just try something. So no, I have to look up the syntax with the parentheses and all that stuff. I was not sure about that. If else functions, loops, arrays, script syntax, maybe. Bash parentheses, curly braces. Parentheses cause the commands to be run in a subshell. Braces cause the commands to be grouped together but not in a subshell. I don't think that's relevant right now. What if I do vescape is equal to bc-l, and then I just type the command as I would. Let's just do 5 plus 1. Pipe that into bc-l and see if that puts the result into vescape. Maybe I have to group the commands together using the parentheses here. I'm not sure. Apparently this piping, the pipe operator does not work here. What we could do as a workaround would be this and then vescape, and we give that the return value of the previous function. I forgot what the special variable for that was. I don't know exactly. Bash get function return value. No idea. What happens if I just execute that now? So escape velocity, and let's say we provide the values 5 and 7. We get a result 6, and it says no computation performed. That's because we haven't exited here. And now we get the result 6, which is 5 plus 1 piped into BC. So that seems to be working. Yeah, that seems to be working. So that outputs the result directly to the standard out. So that's actually already fine. Of course, it would be somehow nice to create a variable escape velocity and then echo that ourselves, but this is also fine. And now we can perform an actual computation. Let's echo square root, and let's pull up the formula for escape velocity again. Square root of 2 multiplied by the gravitational constant, which is this. Two multiplied with the gravitational constant. I'll give this a variable, a constant variable input here, multiplied with the mass divided by the radius, multiplied by mass divided by the radius. And then we can assign those variables here. G is the gravitational constant. 6.67 multiplied with... we can just give it a string value. I think 6.67 multiplied with 10 to the power of minus 11. And the mass is the first input argument. And the radius is the second input argument. Put in a string. I think that might work. Let's try. And if we compute, oops, as you can see, we get a result, and that is an incredibly small input velocity, because the mass that we input and the radius are both very small, 5 kilograms and 7 meters of radius. So that's an incredibly light planet, which won't work. And here's the interesting part. Now we can even specify very, very large values. So let's input the Earth's mass, Earth mass, 5.972 multiplied with 10 to the power of 24. So let's do 5.972 multiplied with 10 to the power of 24. And the radius is, I know the Earth is not a perfect sphere, but the radius is approximately 6,378. 6,738 kilometers, so multiplied by 10 to the power of 3 meters. And let's see if our compute script is now able to put all of that into the BC process and perform a valid computation, perform a working computation. Let's see. And we have a result. This is allegedly the escape velocity in meters per second. So in SI units. We could technically also return it in, well, it depends on what you want to do with your program. We can do this. We can echo the result in meters per second. Let's try to do that. I have to find out how to evaluate a function in a string. Evaluate function in string bash. Maybe let's do it simpler. That's confusing. Without obfuscating the syntax ourselves. Let's do the following. We compute the escape velocity here and put that result into a variable. Oh no, this doesn't make it easier. Evaluate string expression. What if we do this? Does this work? Oh, this might work. The syntax might work for evaluating functions. Let's put that in a string and let's echo that string. And here we can now attach something. We can attach the unit here, meters per second. If that works, I'll freak out. Doesn't work. Obviously, it doesn't work. Syntax error. Oops. Probably that's because the -l in the parentheses cannot be separated out by bash. So let's give this a bit of space. Let's see if it works now. No, it doesn't work. Ah, damn it. That would be super nice. No, Google is misunderstanding me. I want to evaluate this function and store the result in a variable. How hard can it be? Bash store results of command in variable. Oh, that's probably very simple. It's that. Ah, do I have to use single parentheses? Ah, that might work. Yes, that works. Awesome. Super awesome. So let's try. And as you can see, we now have a computation that outputs the escape velocity together with a unit, meters per second. But we can also output that result. We can convert that result into kilometers per second or per hour, which is more useful. So let's do escape and give this the variable value. This. So this is the value of that command, the escape velocity in SI units. Now, to output it in meters per second, all I do is I reference that variable here because it is already in meters per second, and I print it to the console like such. Now, if I want to convert it, I can do vesc in kilometers per hour, and let's convert that. And that is equal to v escape echo. We have to echo v escape into BC and divide it by 3.6, I think. Because 100 kilometers per hour would be 36 meters per second. Could that be? No, what am I talking? Something like 30 meters per second. Yeah, so we have to divide. So we echo the value of v escape into BC dash L. And then we output v escape kilometers per hour here, kilometers per hour, just like so. And the escape velocity would need to be divided by oh, 3.6. I think it's, you have to do it like this, and then this quote has to be removed. And I think now it's fine. So we're taking that result, dividing it by 3.6 and echoing it into BC-L, and then storing the result in KMH, and then echoing that as well to the console. Let's see if that works. And we now have the escape velocity in kilometers per hour as well. But this is a ridiculously high number. This is impossible. It's impossible that this is correct. 3 million kilometers per hour. No, this cannot be correct. So there is definitely an error somewhere. Either it's in the mass I provide here, or in the radius. So either it's in the provided values or it's in the computation. Now we have to figure it out. So the radius of Earth is 6,378 kilometers. We can also just write that to the console. Echo no, but, well, we are providing those as inputs. I'm wondering why the R is not syntax highlighted here. So echo Earth, or mass is, can I just do this? Radius is this. I don't know if that works or if I have to provide curly braces. Apparently I don't have to. So let's clear again and see the result. So mass is this. So this seems to be correct. And this seems also to be correct. Now, Earth mass 5.972 multiplied with 10 to the power of 24 kilograms. should be fine. That means that the issue is more likely in our computation. Let's look up the escape velocity again. We take the square root over 2gm divided by d. Square root over all of that. 2 multiplied with g multiplied with m divided by g. I think an issue could be that I provide the quotes here, which probably I shouldn't, because those would be misunderstood by BC as some ASCII characters, which probably also have values. I don't know. Let's try. If we, for example, write to the console 5.972 multiplied with 10 to the power of 24, what's the result? It's this, which seems to be correct. What if I do the same thing but in quotes? Yeah, that evaluates just to the string. So this is not a mathematic expression. This is just a string. And BC can't handle this. So we should strip our inputs from the quotes. And now I would expect correct values to be computed. So the mass is this. Radius is this. We can even provide units here. For that, we have to probably put the mass in curly braces. And that seems to be what the curly braces are for. So let's try again. Compute escape velocity of that, and let's try. And the result is that's very, very fast. This cannot be correct. And by the way, the result is the same as before. And I think that is because I put my variables in quotes as well, which may not be desired. So maybe it makes sense to store the expression here in an expression variable. Then we can echo the expression into BC, and the expression itself, we can echo that to the terminal as well. Expression to be evaluated is expression. So let's see if that works. Yeah, and the expression to be evaluated looks correct. I know why. That's because the expression to be evaluated now breaks the precedence, because I am expecting the precedence to be evaluated as in this expression string here. But since the variables are expanded and they are now since the variables are now expanded, the division acts on this 6,728 only, and then the multiplication here multiplies the entire result of that. So this is evaluated first, and then this multiplication is appended afterwards, is evaluated afterwards. So what we have to do is we have to make sure that everything here is put into parentheses for proper precedence. I think this first line of, well, the numerator doesn't need to be put in the parentheses. It's just the denominator should be. Well, but okay, God knows what people will input here in G and M. If they input other complex computations with sums, then this will break precedence. So this should be fine. If we want to make it extra sure that everything is correct, we should even put the individual variables in parentheses. Just like this. And let's try to compute. And we get a result. So the escape velocity is 10,800 meters per second, which is 3,022 kilometers per hour. Let's confirm that online. Earth escape velocity in kilometers per hour is 40,000 kilometers per hour. Ah, I know why. I have to multiply with 3.6 and not divide by 3.6. Okay, let's try again. And yeah, there we go. So it's approximately, according to this guide, 11.2 kilometers per second. And 40,000 kilometers per hour. I think this is adequately precise. That depends, of course, on the values input into the computation. So we found that it is 10,800 meters per second or 39,000 kilometers per hour. I don't know which values this AI overview here used. Yeah, I think it's just a difference in the values provided to the computation, although it bugs me a bit that it's not exactly the same. Maybe we have to refine the G. So the universal gravitational constant is this, and it is 6.67430. What's the difference between those two? 6.6743. So this should be more precise now. And aside from that, which radius is used in those computations? Earth escape velocity. And they used a mass of 5.9736. 9736. I also used a different value here. 9736. And a radius of 6,371. 6,300? Oh, I have mixed up the numbers here, I think. 371. Okay, let's compute. And now we have the accurate numbers. So we have the result that the escape velocity is 11,000 kilometers per second, which is 40,000 kilometers per hour, which is ridiculously fast. And that matches roughly what we see here. Here it says 11,186, and we have 11,187. Awesome. That's good enough. Depends on precisely which values were input into the computation. Okay, I think that's enough for this video. Now you know. And I found it quite interesting because we use such a non-traditional way of computing stuff. But it's quite powerful because it's all possible in Bash. And every single Linux machine on the planet runs Bash. So you can generate your own script to calculate anything, whether it's just plain integer computations with some function or with some process results, whatever. Of course, these were super dumbed down examples, just summing up numbers or computing the power of something. But you can also create more advanced calculations, for example here for the escape velocity of some celestial body, and have a result computed for you in Bash. And it's super powerful because you can create your own script that contains computations that you use frequently. I don't know what you study as a major, but if you're a physics major, for example, or a math major, or whatever, engineering major, there are some things that you frequently compute, and you can just create your own calculator that way, give it make it support a couple of different functions, for example, escape velocity, whatever, acceleration times, free fall, ballistic curve. I don't know, it doesn't even need to be just physics, it can be anything. Computations about time passed for something. You can do anything. Anything you compute occasionally. And you cannot do it all in Bash. And even though nobody ever uses Bash for computing stuff, I find it quite nice to have looked into how it works. And even though I just wanted to look into crunching numbers in Bash, we have also learned quite a bit about the syntax, the if-then statements, while loops, for loops, the special arguments here. So this was quite interesting. If you also found it interesting, then stick around and see you next time. Bye.